Yay! So, I want to move things from here. Hi, everyone. So, welcome to this month's webinar, the end of the year webinar. And today we're going to talk about API testing, I think. That's what it says on the screen. This is going to be a little less technical than the other webinars that we did. No typing today. It's going to be a bit technical, but it's more about what we need to think about when we're testing APIs. And sometimes it's not as simple as it looks. Imagine that. So today, I welcome you to the webinar. I'm Gil, and I do a lot of stuff. And this thing I'm going to talk about is from my new course, API Testing with Postman. And apart from that, I'm doing training and consulting on all kinds of things with developers and testers, and everyone who wants to write better software. That means TDD, unit testing automation, clean code, API testing, lots of refactoring, and other cool stuff. I'm the author of 2 books, Everyday Unit Testing and Everyday Spring Testing, which we're not going to discuss today. If you want to get in touch with me, well, in the next upcoming hour through the chat window. If you have any questions, put them in the chat window or the Q&A tab, or what? I think the Q&A tab is still there, right? Yeah. So I'll try to look at the chat window. Don't promise anything. So if there are things that I miss, put them in the box for later on. And also you can find me on Twitter and other places when I go into these places. If you want to know more about my services, on the training, the course I'm going to discuss today, let me know, gil@testingil.com, or Tal, who has a lot less jokes today than she usually has. Okay. So APIs, application programming interface. It's basically how another computer talks to our computer, basically. So software exposes some kind of interface, so other software programs can talk to it. And if you look at the different types of software that we write today, this is basically so fundamental, hopefully more qualified than what we see in this picture. And everything that is basically server-based, which is a lot of things today, exposes usually REST APIs, because that's the standard today and standard architecture. And basically, if everybody is writing APIs, everybody should be testing APIs. However, it's not that simple. So sometimes like a developer tells a tester, like, go test this API. Is it that simple? Well, here's a story. One of my clients, when I got in like a few years ago, so there was a whole team writing APIs. This was a developer team. They were writing their own tests, their own API tests, and they didn't have any methodology in place. So they were thinking, how would you check your coverage? They didn't have any coverage tool as well. So what they did is that they have a very long Excel file with, in one column, they have all the APIs, and the other column had a checkbox that if they wrote a test for that, if it was covered, we check it. So people with a little bit of experience would understand that this is not a good way to measure coverage. But at that point, it was, by the way, a very interesting way to see how reporting requirement from management imposed a working methodology, because this is what management wanted to measure, the coverage, and this is how they measured the coverage. So that meant that a test for each API would be enough. Later, we actually saw that a test is not enough, even if it was a single test, even if it was a good test, because sometimes there were no asserts there. Sometimes they would check the status, they wouldn't check the response. So even these little things can come up and tell you that it's a lot more complex, we think. So yeah, it's not as easy as it looks. And what I'm going to tell you about today is really how it's not as easy as it looks, even if you think that, yeah, we know all this stuff, there's always more to do. And the idea is not to, well, I'll show you at the end what happens, but the idea is to open your mind and accept that since API testing is so complex, we really need to think about what we're going to do in terms of test plan, how we're going to, what are we going to focus on, what are we going to execute, and what are we going to report? Because this is very important, because it could be a lot of stuff. This session is, like I said, it's not technical. It's not meant for developers. Of course, developers are should know this as well. But developers who did a little bit of automated tests, like unit tests and stuff like that, see an API test, it's like another thing that they've done before. But for testers who are testing applications, testing workflows, it's a bit different, because an API basically is like a bit of code. It's sort of a bits of code, but usually when we think about an application or a workflow in application, the code thing is kind of abstracted away, and we think in terms of user workflows, and I go from here to there, and I enter that, and I see that. With APIs, it's basically its translation layer from these kind of workflows into bits of code. So developers who wrote a bit of unit tests, stuff like that, they kind of understand there's sort of a border around their system. They understand what this border is, because they know the code, and they know, well, it starts here, it stops there. This is what we're going to cover. And when they write API tests, that's the same. They know what code they're going to go into and which code they're not going to go into. However, when we look at it from the applications perspective, meaning an API is like just one unit of this thing, when testers are not really, they don't really know which code they're actually going to, or they don't have the borders of where the limitations of what they're actually testing, it's a bit of a mindset change. So if you're expecting me to tell you that don't go into the code and see what's going there, sorry to disappoint you. It will give you a lot of leverage, a lot of benefit to do that. But I'm going to talk about the black box later. The thing is that if we're actually, if you don't do this mindset change, we're going to miss a lot of things. So we actually need to do and to understand that APIs are basically bits of code, and there are specific bits of code. And when we're executing them, we're executing those bits of code, and they are going to be either running by themselves or dependent on other things or impacting other things. So all these things kind of go into what we need to think about when we're actually testing. Like I said, there's a course for that. The new course is API testing with Postman. I'm going to talk about these things too, but do a lot more in-depth and hands-on stuff in there. So in your Zoom thank you letter, that email that you're going to get, there's going to be a coupon there for the course with a discount. So if you're interested, use that. So let's talk about what I brought you here today. All kinds of things that we need to open our mind and think about when we're testing APIs, or hopefully before we do that. I think you've gathered from what I was talking about until now that it's not going to be simple. I'm going to start with the bits and pieces of what in an API. It's a REST request usually. And you can see on a screen, basically, a REST request actually is kind of a combination of four things: the method and the endpoint. The method is the post or the get. The endpoint is the URL. I kind of put the parameters there in the URL as well, the endpoint. We also have the headers and we also have the body. Headers and body are sort of optional, maybe. Method and endpoint are mandatory. But if you look at these things, you can see that assuming that an API is the method plus endpoint, we can do a lot of combinations of parameters, headers, body. And there's a lot of things that happen below the coding layer that kind of translate all these strings that we put in Postman or any other browser or any other tool to translate them into to code and actual running types and stuff like that. So just a single API can be a lot of things. One of the things that I did when I worked with a client on reporting coverage was that we looked at the signature of an API and we looked at the number of parameters, and we said that if you need to check this, what would be the bare minimum of thing, even without looking at what it actually does. And we looked at the number of parameters. We said that if it doesn't have parameters, okay, go for one test. Like we're talking bare minimum without even looking at what it actually needs to do. One parameter, try two things. Two parameters, try four things. That could be combinations. And that's just the parameters for the endpoint. And you can play with header fields and you can play with different body. Like the code itself doesn't know what you're sending it. It could be like a string or a JSON or a number or whatever. And you may want to see how it behaves. And this is like something that's going to be a theme here. I'm not talking just automated tests, automated checking, where you actually know what's going to happen. Sometimes you don't know, and because these are complex systems, you actually want to learn. So there's a lot of exploratory testing to do around API. And you can play with that and see how things are going. Now, that's just for one thing. Imagine that you have you want to check workflows in terms of APIs. You have multiple APIs. You want to run those. So single API usually doesn't give you, there's not much meaning in that. Is that API working okay? Great. Does the application work? Who knows? So we actually need to test a lot of APIs and together and combinations of them and in different contexts to see if the application actually works. So just off how a request is built, we can do like a lot of combinations. So it becomes complex just because of the structure of what we're doing. And that's about the part that we're actually sending. Let's talk about the part that we're receiving. So I don't know if there's the starshop.com. I invented this for the purpose of this session. I'm not sure if you can actually buy stuff from starshop.com, but let's assume you do. So this is a post request and a URL, and we send in item equals 1701, and this is the response that we're getting. Now, you'll have a lot of experience. You look at it. How do you know that this is what is supposed to be? It's a very good question because I thought about it myself. What is right here? So let's take a look at what goes in our mind when we're looking at this response. And remember, this is a very simple response. When you get like JSONs, lists inside lists inside lists, it's going to be a lot more complex than that. But let's see what goes in our mind. So we kind of correlated the item ID that we got with the one that we sent. So probably okay. The item name, okay, we might need to know in advance what we're actually buying. It's a star shop, so a starship makes sense. Let's talk about the transaction ID because it's interesting. It looks like a GUID, right? Like a global universal ID, which actually is because I created that. But you may think, well, is this part of my assert? Is this by my pass fail criteria? Do I need to look at it? And most of you will say, it's just a GUID. Why do I need to look at it? But it can get interesting though. I'll talk about that later. So obviously, if it is a GUID, I probably will not write an assert for that because when I run it next time, it probably will not be the same GUID. Transaction date. Is it the right date? How do I know that? Usually, I need to set up data. I need to set up data I control, and an API by itself that tells me that I don't know anything about that. So I need to be in control of stuff. Finally, total paid. Well, obviously, is that the right number? Do I trust it? Is this the right currency? Is this the currency that was paid, or is it the currency today? There's a lot of questions of what comes out as a good or exact response, which leads us to the next thing. So this is only by looking at the response and what comes out. Next thing is, well, how do I automate that? So obviously it's not easy, because from all I was talking about was basically selecting what is important in terms of like passing or failing my test. But it still can be a bit more complex than that. So this is what we got, right? We have the GUID. So probably I'm going to ignore the GUID here, the transaction ID. I'm not going to test for that. And transaction date, I don't know, may do that. But for the rest, I can do something like that. So this is a script, a test script from Postman that I wrote for that. And the test is in Postman, you run this after you run the API. We probably can see what's happening here. And the test is that the Starship was bought. Not a very good name, I know, but it needs to fit in the window. We get the response, we get the JSONs out of it, and then we write a couple of expects. I'll start with the item ID because it kind of like compares it with an equal. The ID has to be equal to what I say. Item name, though, for example, doesn't have to be an exact name. We write assets like that all the time. The total paid is interesting because is that the right currency? Or maybe I need to put in something that will make sense, because when I'm working against a living system, semi-living, something like that, I will not get always the same number, but it has to be like in a certain range. Other that doesn't make any sense. So I can do a lot of automation around this, but this requires a lot of understanding of the behavior that is expected of this API. Remember, it's not the system, it's the API. Something goes in, something goes out. Sometimes we don't even see that. So we need to understand what it looks like, how you operate it, and what's the meaning of things coming in and coming out of it, so we can actually automate around it. And like these are 3 lines. I actually saw like something like real data coming out, like pages and pages of code inside Postman, which was kind of a very awkward because Postman is not really a development environment. But there's a lot of code that you need to manage, and yes, you need to understand code and write it if you want to automate, and write it well so it will be maintainable. So there's a lot of thinking about what is right, or what I'm going to test and what I'm going to ignore. So dates. I was talking about the currency that we were talking about, and when I prepared this, there was something funny that happened. I was talking to a friend of mine who's working in a software company, and it was just after Israel went from daylight saving time to winter, no saving time, and actually had a bug. So daylight saving bugs are still happening. Why? The developers wrote very clever code. It doesn't really matter, but things can be happening because of dates, although we don't really see the dependency in the API itself, right? We didn't see anything. So it could be like this. It could be a dependency on something like a leap year, like everything that happens on February 29th or doesn't happen. What the bug that they had didn't always assume that time is linear. Imagine that. So let's look at this, right? I was asking you whether this, well, the currency, the total paid field is the right thing. But it could be impacted by when it's going to run. So well, was it run on Black Friday? Because I need to look at the answer and ask it in the context of whether there was a sale there or not. There's something, you know, when you run different sales, price is impacted, and you might want to see how it's getting this impact. So if the number that you see is really based on that. So that will tell you that when we're testing this API, single API, we need to set up or create terms where things happening or simulate the things that are not always like linear time, or some events like Steam sale. a lot of games are under sale, so they are discounted, or they're not, and therefore what we see can be something that is impacted or dependent on something else under the system that we can either set up or create, or we cannot create Christmas every day. Not sure if that's a good thing or a bad thing. I do have a friend whose birthday is on February 29th. She would probably want more birthday presents than once in 4 years. Now, for people who were actually who came to my last session, it was about Spring testing. I was talking about cache. This is something I'm going to talk about from a different perspective, but a few things. Caching is something that is kind of encouraged in the REST architecture. If you're having like things that bring you data, like GET requests or sometimes updates, kind of encourage you to cache things. What is caching? Basically, it's a performance enhancing thing. So let's say you have a popular item like a Starship, and there's a lot of people who want to get information on it. So every time you go to this API, you call it, and it goes to the database, searches for the information, filters it in, gets the data, packages it, and gets it back to you. And if it's popular enough, you'll say, well, why should I go to the database? I will just keep it here on the server, cached. This is what cached looks like. So instead of every time that the request comes, I will just give you the data. So far, so good. So again, I invented something like a GET request here that gets the information on our item. And I added something called remaining. How many things are remaining? How many items of this type are remain on the shop? And obviously, this is something that probably shouldn't be cached. But you didn't know that, because caching is something, like I said in last time, it's a design decision. It's not something that from a black box perspective, you don't see. So you don't know if caching is there. If you're calling this, you don't know if caching is invoked, but you'd like to know. So you want to see if it's actually remaining one all the time, if it's remaining one, even when people are actually buying it, if it's cached or not, because there would be a bug there. And you might want to know how to clear that cache, when it gets cleared, when it doesn't get cleared. And like I said, if you're treating the code as something that has no relevance to you because it's a black box, you're missing scenarios that you assume that everything's going to be right. But if you understand there's caching somewhere in the system and it's used in different scenario and it gets cleaned in those same scenarios, you'll be able to test if they actually occur, if they occur correctly, if they behave correctly. And if not, maybe you can do something about it to operate things, to check more deeply than you can do without even knowing that this thing exists. It's not just behavior, it's how the code behaves, and it has a lot of impact on what we can actually check. Imagine if this thing was actually cached, what would be the impact of a real business? Let's move on to Doc. No, okay, so API. It's never enough. You can always call it more than once, and it has an impact. It has a few impacts if you call this more than once, which kind of we miss out in terms of automated tests, right? If you check the API and check what comes out of it, and we don't call it a couple of times, we might miss out on things that's happening. So again, going back to our post here, and things that we can check, like you look at the GUID, like I said, like, I told you, you trust me, that I created it with the GUID generator, but is that really true? Maybe if you call it a couple more times, you'll see a pattern of the latest digit coming up incremented, which might tell you that something can be done lawfully, unlawfully with this thing in terms of security, or things that you might want to see that might be a behavior in the system. For example, if you keep buying, if you invoke this API over and over again, maybe the price will go up because there will be less item to buy. So running it just once, we kind of miss out on these kind of scenarios. But we need to be aware of internal things, either we want to learn, or things that we assume on the system, like they're good, or things that we might want to see if things are going to stay the same or not, and check out according to the requirements, the spec, that what everybody else in the team can tell us about the system, if it makes sense for our types of business, or types of application to actually go through. There's one more thing which leads us to my next thing, is there a limit to calling these posts? Maybe somebody will take care of that, or will get different behavior. And that kinds of calling it more than once. Let's talk about what calling this everyone together. So what happens when there's a multiple concurrent calls? I think you missed the word S at the field transaction date. I'll fix that next time. Yeah, so multiple calls concurrently. So obviously you're probably thinking, well, what can happen? Well, a lot of things can happen. So let's look at this API again. Like I said, let's talk about the GUID, but if there's a pattern here, maybe interesting to see. If there are multiple calls, maybe someone gets before the other one. And then do we expect to see the same order? So if there was one starship remaining and two people are calling these posts at the same time, what will happen? Is the first one if it's supposed to get the starship and the other one is going to get an answer, well, we're out of starships, is one thing. Maybe it's not. It really depends on the business of the application. But we might want to actually put test where we get multiple things in, and we'd like to check if things are going by order, by what order, and if there's nothing left to buy, what do we do then? And again, this thing, along with the other things that I talked about, and the things I'm going to continue talking about, is about thinking about, well, it's a bit of code. What happens when you call it in different contexts? And we need to understand this kind of context, a lot of context then, and the context that we actually think about and know about, the ones that we don't. So let's talk about the different kind of context worked in my machine. So a lot of times we're testing in a context or in a machine. The guys who were actually testing the daylight saving time bug, they were testing in a context of time is linear. Everything is okay. And time always moves forward. We never move backwards. Therefore, we assume some kind of behavior. But any kind of configuration is an assumption. And most of the time, like 99% of the time, where we're testing, whether it's our local machine or a stage environment or joint dev stage environment, heaven forbid, is going to be different than what we have in production. And therefore, what we're testing is different than what's going to be in production. We say that it's like we can assume that if it's worked here, it can work somewhere else. But is that always true? This is one thing that is like we kind of know that exists, because, but we don't always look at that. Do we have a gateway in production? If we have a gateway there, do we have one in our staging environment, in our testing environment? Can we see this kind of response when we're testing locally, where I obviously don't have a gateway? So when we need to be aware of different configurations and the differences between where we are testing and what we see according to what we have in the production, because some things we will not see. I talked about multiple calls concurrently. Like if we have a gateway, a load balancer, something like that, that might impact where the code will actually run. Think about it. So let's say we have a gateway, and this gateway actually tells, well, we can't handle no more requests here, so I'm going to divert this request to somewhere else. So our assumption that everything will go running on the same place breaks down in production. We need to be aware of these kind of changes and what they impact in our test plan. So like I said, we need to learn more about things that happen. But up until now, I talked about dependency, context, all these kind of things that we kind of make sense to us because, like, you understand what I'm talking about. Do you understand what I'm talking about? Because remember when I told you that APIs are bits of code? How do they become these kind of bits of code? Like every software, basically what we have some kind of translation between a vision or a diagram on the wall or whatever to bits of code, to software. And not only that, it's some kind of division and organization of code, the APIs. This bits of code goes under this kind of API, and these bits not. They're going to be under another API. And this translation is usually a design decision. It's not something, maybe it's a product decision. Usually it's not. It's something that is an architectural and design decision, a development decision. And when we do that, when we translate from user or system level to code level, things happen. I'm going to give you two examples. One is very, very weird. Now, I found out doing my research that 418 is an actual status code. A 418 called I'm a teapot was entered as a April Fool's joke somewhere, like when they were doing the RFC. It was fine. It was fine and funny, and it was fun enough to keep it in there. And the text says that this code should be returned by teapots requested to brew coffee. Funny, haha. But you can, or the developers building your application can actually implement that. And when you get a 418 for your business application or our Starship, what does it mean? Well, it means, if we're not talking about the funny business, it means something. That means that the developer, architect, whatever, person who's translated it from user domain to code domain said that this response will tell you that something happened. The smallest thing that you probably know, there's a 200 which is okay and 201 which is created status. I don't have to say 201 if something was created. I can give you 200, and I expect you to understand, because you read the documentation or something like that, that the item was created in there. But I'll give you a more concrete, more grounded example. So let's say we have this API and trying to log in, and if you try to log in with an admin more than 3 times, you get more than 2 times, you get locked out of the system. So you do the API once, you get 401 unauthorized, great, and you get a message, go away. Do it the second time, same thing. Doing the third time, you get an 401 unauthorized, you get a message, this means war. Now, this message gets translated to you get locked out, which means that other APIs are locked for you. A lot of impact going on, and you, the user, not the tester, the user needs to understand the impact of this thing from the message. So an implementation detail needs to be translated back to what it means in terms of user workflows and scenarios. So meaning, the translation of what the developer thought he was putting in and what he exposes, you may not speak the same language. You may not see the same behavior, like it's the same API, different parameters, call it once, call it twice, see something else. We can change the semantics of the same API, like with this scenario. Let's say there's a reset period. Like if you call the API once, twice, not the third time though, and you wait for 15 minutes because the system resets after 5 minutes. So what happens is that you won't get this means war system, you'll go to stage 1 when you call the next time. So it's not going to be the third one, but it's going to be like the first one. There's a semantic here that you don't see on the API because things change over time because of something else that goes on in a different part of the system, like the timer. So the semantics might change based on something completely different. And you're going to use the same API thinking it's going to mean something once, but it's not going to be the same actual thing that you actually meant. So I talked about a lot of things, and the final point is, even when we think we know what we think we know, we don't know much. Where do you get the information of how this thing is supposed to work? We kind of started that in the beginning. Usually we get like some kind of documentation, or the developers tell us, or whatever, kind of collect this information of how this thing is supposed to work correctly. Even not correctly, even if we play with it, if we explore and something strange happens, we need to be aware of what is actually strange and what is not. And we use a lot of things that to do that. A lot of experience tells us that in other applications, these kind of things work. If we're new to API testing, it's going to be It's a whole strange new world. So where do you get it? Is documentation the correct thing? Well, it could be, it could be incomplete as well. It could be a whole lie. A lot of the times we don't have documentation, as when we do the documentation, it's not complete. Like take this our API, for example, it tells that it will return a 200 if everything works correctly, and the documentation tells you allows buying an item, returns ID and price, always documents item count. Cool. Really? But is that complete? What does that mean that it returned to us the GUI, the transaction ID, and the date? Is that a bug? Always decrements item count. What happens when it gets to 0? Will I see the numbers going down or not? Remember that the people who actually write this documentation translate what they know to whatever they think the user will need. So the developers who write this kind of documentation, so well, somebody is going to read this API and would like to know what to expect at the API level, not about the user level. So we'll give them what they need because they're going to do this. They're going to get a response. They need to do what to know what to think about it. But this is as good as it gets written, as good as the knowledge of the developer, as good as the developers understanding of the context. Sometimes they don't have the context because they're building this set of APIs, but the context is a lot bigger. Remember, the getting locked out of the system could be a very big thing, but they're working on this and they're not even aware of that. And what's you'll see a lot of the time missing is the context or the translation between the API level and the workflow level, the scenario level that the user sees. So even when you get information, you don't need to trust it completely, as you probably don't know already. So how bad is that? Is API testing is something that we just need to say, well, it's too big, it's too complex, can't do that. We need to pick our things, go into Nepal to a shrine, a temple, and sit there instead of testing stuff all the day. First of all, it's an option. Not going to tell you no, but it goes back to what I told you at the beginning. API are bits of code. That's nice, but it's not the application. It's not what really interests someone or another computer used by someone. So when we're going there to test an API, and testing an API, a single API is really meaningless. We needed to do what we're good at, creating test plans and executing them and reporting on them based on system risks, interesting scenarios, and we don't have all the time in the world to do all these things, but we do need to expect all these kind of things and a lot more can happen because not everyone thought about all the things at once, like you did because you went to this webinar. So errors and bugs can come on different ways because we're looking at APIs, not because how they're built or how they were written or what's the entry point, but how they are used in a context of application. And if we did that, we can start doing something that we're also good at, prioritizing. And we can translate, well, these are the APIs that interest me, or these are the APIs that, yeah, I'd like to know more about them, but they are less important in terms of risks, in terms of business risks, in terms of money, stuff like that, because I would like to put a lot more time testing the things that belong to the workflows that are important, and we'll define as a team what is really important, but we need to do that. And then we have, after we said, well, we're going to focus on these things, features, workflows, we can break from them the APIs in those contexts that interests us. Because we can do a lot of testing with APIs. And if we had a lot of time and a lot of resources, a lot of computers, a lot of things, we would create a very big report. Usually that's not the case. So is it all bleak? No, but because it's big and huge and time consuming, we need to approach it methodologically in terms of what is really important testing is risks. What is important that it needs to work? What is important to learn? There's always time to learn. Well, not always time to learn. There's always the opportunity to learn more. But we need to focus not on the APIs, but on the workflows and scenarios. And that's basically what I wanted to share with you today. Like I said, there's a whole course about this, and I'm going in details, not just about the technical stuff of how to do stuff with Postman, but also a lot of the things that I talked about today, like the thinking, the methodology, how to think about testing, what APIs really mean, and to think about them in different contexts when we test them. And that's basically it. If you have any questions, put them in either the Q&A or the chat window now, and I'll try to stop moving my head back and forth. So that's it. Q&A question. When writing unit tests, it's relatively easier to make sure there is code coverage, but via API testing, how does one come to conclusion on coverage? It's built based on test scenarios that we come up with. Okay, so very good question. Even in unit testing, you can check coverage, but what does it really mean? Are you checking the right code, the important code? So even because unit testing coverage is something that is easy to do because everybody cracked the technical trick of how to do this. It's not very complicated. We're kind of looking at the under the flashlight. Does it mean anything? No. What is important is the right code or the important code covered. And this is something that we can't do automatically. We need to review stuff and think about what is important. And the same thing applies to API testing. It's not about is API covered or not. It's more about our workflows, including this API, covering the important stuff. And is there a number? No, probably not. And probably the number does not have a meaning. And also, it doesn't really, if you compare it to other APIs, does it matter if something has more coverage than another? No, because other APIs may not be as important as this one. So let off the coverage thing in terms of measurement and numbers, and think about, well, are we checking the right scenarios? And if you are, good. If you are checking the most important scenarios, great. You're probably on the right track to do that. Coverage in numbers and code doesn't give you a lot good stuff. Although you can actually do that, not today. With a lot of effort, you can actually check, test, coverage of API covered by tests. But again, it doesn't tell you anything meaningful in terms of, well, should we release this version or not? Okay, thank you, Mithun. And next questions. Can you please explain a little bit about Blackbox? Okay, so Blackbox means that when you're testing, you assume that whatever you're pushing buttons or calling APIs or operating, you know nothing about how it's written, designed, or what's happening behind the fence. You're interested in just putting things in and looking at what comes out. Now, when I came up as a developer, I was trained to think like that. They actually told me, don't tell the tester how you've written the code, they don't care about it. But that's not true. Because if we have information of how the code is written, then we can actually think about different scenarios, and this is like white box testing, we know how the code is written, or gray box testing, which means we partially know how the code is written. We can think of different scenarios and try to see if they work or not, or how they work. So black box in our language today in API testing means all we see are APIs calling, we send in parameters, and we get back and body, request bodies, and we get a response. And without any information how this response gets created, we don't know if there's a gateway behind there or not. We don't know where it's run. And black box means really you don't care. And I don't believe in that. Black box testing allows testers to do what they need to do, which is report about the behavior of the system as much as they can. Because if they know how the system is built, they can report better. So that's a bit about black box. Thank you. That's the second one. What do you think about Swagger documentation? Is it a good way of getting knowledge about API? So Radoslav asked about Swagger documentation. Well, Swagger documentation is usually written. Okay, what is Swagger? Swagger basically is a tool. It's a tool that allows development teams to publish to anyone who wants APIs. What does it mean, publish? Publish the information about them. You can look at a Swagger server, and you can say, well, this version of API can return these kind of statuses. It gets a body in this kind of schema. It allows these parameters to be optional, these are not, and it returns response in this kind of schema with all kinds of information, and it allows you to tell what this API does. So that's the tool. There are other tools to do that as well, but that tool doesn't do anything because someone, usually the developers, need to write what these things mean. And you can find many discrepancies in the understanding, in the description, missing details like missing statuses, missing information about mandatory fields or stuff like that. So it really depends on who writes it, and even a bit more, the person who reviews that. So the Swagger documentation is as good as it's written and as it is reviewed. If you trust these people, well, good luck. Never trust these people. Actually, look at that. Be part of the review and see if they actually do that. You'll see a lot of discrepancies. So it is a good tool, and if the team uses it, they probably use it okay. Do they write the important stuff? That's a completely different answer. There's a whole lot of processes that you can be part of or cannot be part of because it might be a different department doing that. And just because you have Swagger doesn't mean that you have good documentation that you can trust. So, but it's a source. It's a good. If you have it, it's a source. Malta asked, we test code and workflows through the APIs and ignore unit testing. Your thinking on this? My thinking is that you're missing out on something. And that something is if you have correlation, like this kind of correlation, between an API test that goes through this part of the code with unit tests that go on small parts of that code, and you have only the APIs, when it fails, you don't know exactly what went wrong. If you have those and unit tests, you can know where the problem is. It's either in those boxes that are tested or outside the boxes that are not tested. So the methodology I think and I advocate is that you should have a lot of overlapping different types of layers, and that includes unit testing and API tests and end-to-end tests and whatever you have inside between them. Because when things are failing, it's not that you'll get the information, because getting the information is cool, and but you'll get the information if you even if you only have API tests, but it will take you longer to find the problem. So having overlapping of tests on the same code shortens the way to a solution. So I really believe in like multiple layers on the same code of tests. Thank you. What do you think about gRPC APIs and how their testing compares to REST APIs? Ooh, that's a very interesting question. I don't have a lot of experience with gRPC. However, it still comes down to tooling and frameworks, and then everything we talked about today is not about this. So every tech stack has its own advantages, disadvantages, and different architectures and support. So that it can be anything, anybody's choice. When you're coming to test it, you don't really care about how things are called, but you really care about the meaning. And this is what we talked about today. I don't have a better answer for it, not a technical one today. Sorry. And final one, is there something like WSDL to use when writing REST APIs? Some developers keep using SOAP because they want to generate code from the WSDL. It's another question. I think there was, don't remember the name of the stack. There are tools that help you not only generate the code, but again, you'll have to call these in some way in any test stack that you'll use. Sorry, but I don't recall the stack that I remember seeing about WSDL. So it's not about how you write them, but it's also about how you test them, which has to be the same stack. If in Spring, I always come back to what I really know, and Spring or in .NET Sharp, sorry, in C Sharp, the testing stack comes connected with the API writing stack. So they come together, and I'm guessing there's something for WSDL and SOAP as well. Okay, so yeah, I think we're out of time. So thank you for coming today. If you want to get in touch, you can have a lot of things. I have a new Instagram account where lots of these meme things go in there. So thank you for coming today. If you have any questions or so on, catch me up on Twitter or something like that. Not on Instagram, probably. And if you want to know more about the courses, let me know. Go on everydayunittesting.com or testingyield.com. You can find a lot more courses that I do. And at this point, I'm going to tell you goodbye. So have a good evening, morning, wherever you are. And thank you. We'll see you next time. Hey everyone, if you enjoyed this video, be sure to like, share, and subscribe for more. Thanks for the support, and remember, live long and test.